Hello, welcome to my talk on the drug response library, another R package for the evaluation of drug response curves. My name is Martin Hoffmann and I'm working in the Division of Personalized Tumor Therapy at Fraunhofer ITMR in Regensburg. Drug response curve fitting is a main task in high content and high throughput screening, and occasionally we observe problems with numerical convergence that hampers fully automated processing. Also, current software does not provide information on confidence intervals for the response characteristics or on saturation. Now, our DRL package provides this functionality. The most common fit function is a 4-parameter log logistic or Hill function, LL4, and the most often used response characteristics are Emax, the maximum drug effect, the IC50, the half inhibitory concentration, or EC50, half effect concentration, and the normalized area under the drug response curve. Here you see a typical dose response curve, so the blue curve in the upper part. And the Emax is the difference in viability between the low concentration and the high concentration side. And the EC50 is the concentration at which this effect is half. The orange curve is showing the absolute slope of the blue curve, and given a threshold of 0.1, the right-hand side would not have been considered to be saturated, but the left-hand side would have been considered saturated. Now, the features of the DRL package are guaranteed convergence provided by optimized starting values, an automated scaling of the computation effort, and the use of different numerical optimization algorithms. We provide strictly database effect characteristics and can optionally calculate confidence intervals. Also, we have predefined and customizable log logistics, spline, and homeostasis fitting functions and provide custom graphics. In the GDSC data case study, we find that our strictly database characteristics may substantially deviate from the GDSC2 evaluation, and that IC50 confidence intervals tend to be large at small effect sizes as measured by Emax. Here you see the results of this study. So on the left-hand side, you see the IC50 and the Emax values together with their 95% confidence intervals, and the color encoding the F-test p-values for the LL4 against the constant fit. Now, as we are strictly database, our confidence intervals are asymmetric because we are limited to the concentration range given by the data. So we have larger margins and smaller margins for each data point, which is shown on the right-hand side. And you clearly see that for low Emax values in absolute range, the confidence interval is increasing. So the gap at 0 values is due to the specific method we are showing here. So we have other methods where this gap vanishes, but this is the most strict one, and for this case there appears this gap at Emax equals 0. Okay, so on the left-hand side you see a curve with very low Emax, and you can imagine that small changes in the data may result in large jumps of the IC50 values. Indeed, if Emax is 0, then IC50 is not defined. So therefore, this explains the large confidence intervals. On the right-hand side, you see a curve which is not converged or not saturated on the left-hand side, as the viability of 1 is not reached, and also the slope is not going to 0. This is a comparison of the evaluation of the GDSC tool against our evaluation, and you see that the data corresponds quite nicely for the AUC, but do not agree so much for the IC50 values. This is, say, on the one hand, this is due to Emax because of the undefined values of the IC50, so to say, or the large confidence intervals. So if we require an Emax above 0.3, the correlation between the data of the GDSC or the evaluation of the GDSU and our data, our evaluation is much better. Nevertheless, there is a tendency of the GDSC to IC50 values to be higher than our values, and this may be due to the fact that on the right-hand side, at high concentration, obviously more curves are not saturated in the data set. This can be seen here in this cumulative probability density function, where we can see that given a limiting slope of 0.05, 85% of the curves are converged on the left-hand side, and only 67% are converged on the right-hand side, or saturated on the right-hand side. So then estimating for an unsaturated curve the IC50 by extrapolation will result in higher IC50 values. The last slide shows the fitting of hormesis data by log logistic type of functions, or also smoothing splines. Yeah, so just to show that we can do that also with this package. So finally, we see that the DRL package extends the current drug response analysis and guarantees numerical convergence for fully automated processing, and it enhances a range of predefined and customizable fitting functions. It uses strictly database definitions of the effect characteristics, can calculate confidence intervals, can assess curve saturation, and is multi-threaded to speed up computation times. We also provide custom graphics. So thank you very much for your attention, and don't hesitate to ask questions on the website. Bye.